My name is Seth Motarinejad. I'm a data scientist at Microsoft. And I'm going to talk to you today about using R and Python inside of Azure ML. Just to get started here, I have some questions. So how many here are R users? Okay, I see a few hands go up. Python users? Okay, there's usually more Python users than R users. How many here are data scientists or wannabe data scientists? Okay, good. So a little bit about myself. I was in 2012, I joined Revolution Analytics, which was an R-based company. We provided consulting to our clients who wanted to use R for their analytics. And last year, Microsoft bought our company, and most of us joined Microsoft as employees. So I've been with Microsoft for about a year now, and it's kind of part of a big shift in the way that Microsoft is now approaching sort of open source technology. It's certainly not limited to just R and Python. For example, you may have heard that SQL Server is now in Linux as well. So there is a certain recognition that open source technology is here to stay, and that we don't always have to be in competition with open source. We can work together and we can take what's best and build solutions with it. Okay? And today we're going to see an example of that with R and Python inside of Azure ML. Okay, so I'm not going to cover why Azure ML. I think by now you've seen enough presentations that we have a pretty good idea. But I will talk about sort of why we want to use open source technology. Maybe a little bit about R versus Python. It's kind of, these two languages are in some ways very similar, but each of them have certain strengths and weaknesses, and we'll talk a little bit about that. And then we'll move on straight to demos so that you can actually see this in action. Oops. Okay, so we saw Azure ML. Ted was doing a quick demonstration just before I came up here. And what I want to emphasize here is that we want to think of Azure ML as an environment where we can both develop and put into production. Okay? And this is very hard to accomplish. I've worked, for example, with some companies that were using R for development, because R is a language that is very it's very suitable for doing exploratory data analysis with, right? But when it came to putting the code into production, they would actually rewrite the code in some other language because R was a little bit slow, for example, right? So we have these two forces that are a big part of doing data analysis. One is the people who develop code, who explore data, who want to understand all the capabilities. And the other one is the people who are trying to create actual applications out of that data. They want to think about a production environment. They want to think about stability. They want to think about the ability to scale. And one of the advantages of Microsoft Azure is the fact that some of the complexities that come up, some of the differences between, some of the hardships of kind of joining a development and production environment are abstracted away from us, and we can really begin to start thinking about a combined environment, a place where we can develop code, but as you saw, for example, you saw examples of it with turning an application into a web app. We went from a development environment very quickly into a production environment. Okay. So we have an environment that is powerful, it's integrated, and the big piece that my talk is going to focus on is that in addition to everything that we saw, it's extensible. It's extensible with open source languages, such as R and Python. Okay? And this is really important because a lot of people are using these languages. Like R and Python are here to stay. They are very popular among developers, among statisticians, and they are very extensible, and they continue to grow. And you can now put all of that power inside of Microsoft Azure. Okay, so why open source tools, and which ones should we use? Okay. So one of the, probably I would say the biggest advantage of a language like R or Python is that it's interactive. And that means that you don't have to compile your code before you can start looking at results. That means that it comes with IDEs that are just really powerful. You can very quickly debug your code. And within a very short amount of time and a very little amount of typing, we go from raw data into some kind of analysis. We can produce plots, we can look at tables and charts, and we can get a pretty good sense of our data and what we can do with it, right? So ideal for EDA, which is exploratory data analysis. Very good tools for doing visualizations. A vast array of packages. This is especially true for R, where you have, thousands of statistical libraries for doing all kinds of analyses, time series analyses, machine learning algorithm, analyses that are specific to a particular domain, such as genetics algorithm or bioinformatic algorithms, geographical data and GIS applications, and so on. Okay. And what we're going to see today is a special case of using notebooks. So that's going to be at the toward the end of the demo today. And it's going to essentially give us access to a place where we can develop code using R, but within the infrastructure of Azure ML. And finally, just kind of a quick note on some of the differences between R and Python. So Python, for those of you who've been using it, it's a very general purpose programming language, extremely popular and applicable in all kinds of different applications. So people use Python to build basic web apps with. They use it to do web scraping. They use it to build applications with. Nowadays, Python is also a very extensible has a very extensible machine learning library. Okay. R, on the other hand, not as much of a general-purpose programming language, but definitely one that was R was built by statisticians for statisticians. There is a huge repository of libraries that I mentioned before, of just statistical libraries and functionality that we can use. Okay, so building a machine learning model. So we saw an example of that just before I came on the podium here. And what we see in yellow is the place that we're going to focus on for now, right? So the last talk, we talked a little bit about kind of the cycle of a data scientist, right? So a data scientist usually begins with defining a business problem, thinking about the question that we're trying to answer. And from there, we go to collecting data and understanding the relationships between the columns in our data and everything that we have access to, right? So I would say, you know, in most data science applications, we spend a lot of time on the first two. Then we get to the part in yellow, which is sort of putting it into operation, right? So we want to operationalize our application. And so we prepare our data for analysis. With that data, we construct models. And we have tools that we can use to evaluate those models to see if they're doing a good job of, for example, predicting. And then what we do is we iterate on that process, right? So we can improve our models. We can find ways to perform better. We have machine learning tools such as cross-validation for evaluating our models and getting unbiased predictions. And finally, when we're done, the last stage is to find a way to publish that model. Okay. Here's an example of what we saw inside of Azure ML, kind of in abstracted away in a slide. So we begin with some input data. We transform that data. We have a model in mind that we want to use. And so we define our model. We split our data into what we call a training data and a testing data. The training data is the data that we use to build the model with. The testing data is the data that we use to evaluate our model on, right? So it's very important. It's one of probably the most important concept in machine learning is the separation between training and testing data. And if we don't do that, then we have no way of knowing if, you know, tomorrow, if we have new data, if our model is going to do a good job performing on that data, predicting on that data, right? And so the evaluation of the model happens on the testing data. The building of the model happens on the training data. Okay. So there are two ways that we can interact in Azure ML using R with our data. Okay. And the first way that we're going to learn is through a module called execute R script. Okay. So in the abstract, this is what the module looks like. We begin with two inputs that feed into the data, right? So any experiment, such as the one that we're looking at here, is going to have some data as part of the process. That data can feed right into an R module, and it can be processed by R to do some kind of analysis with. And when we're done, we might or might not produce a result, and we can pass that result to other modules along the data pipeline. Okay. So this is what it looks like in R. This is what it looks like in Python. It's pretty much the same structure. The only difference is just the name of the functions and so on. And now we're going to go to a demo to actually see that happening inside of an experiment. Okay, so Ted was telling everyone to go to the link that was posted. I think it's right here. To this link where you can access a document that talks about creating a workspace in Azure ML. So if you want to follow me hands-on, you can do that right now. You can create a workspace, and I'm going to try to go slow enough that you should be able to follow me as we do this. Okay? So if you want to create a workspace, you go to manage.windowsazure.com. Okay, so let me do that. And in here, we have access to our, this is what we call the old portal. We have access to a portal where we can see everything that we have created. Okay? If we scroll down a little, we can see machine learning here. So here's machine learning, and I've already created a workspace. But if this is your first time logging into manage.windowsazure.com, you're not going to see anything there. So all you need to do is click on New, Quick Create, you give your workspace a name, you choose the location, and you choose a storage account name. Okay. So that's really the only three things that you have to do to create a machine learning workspace. When you're done, you press the Create an ML workspace, and if you wait, it takes, I think about 30 seconds, and you should see something like what I'm looking at here. So this will be your workspace. Okay. I can click on that, and I can say Open in Studio, and this takes me to the URL studio.azureml.net. Okay. So from the portal, we provision a workspace, and this is Azure ML. This is where we're going to do our work. Okay. And right now, there's nothing in here, so we're going to do everything from scratch. Right. So I'm going to hit New. And in here, we can begin a blank experiment, or we can go and pull up one of multiple experiments that are already in the gallery for us to explore. Okay? So what I'm going to do here is I'm going to type sample 5. And this brings up one experiment, and that's the one that we're going to be working with today. Okay? So we open that in the studio. And we end up here. So what you see right here in the Azure ML Studio is what we had in our slide just moments ago in the abstract. Okay. So this experiment has already been set up for us. Right? For us, the only thing that we need to do is to click here on Run. And this is going to launch the experiment. At the very top right here, we can see the data. And with the data, we can kind of follow what is happening as we go down. Let me zoom in just a little more so you can see better what's going on. So we start with some data set. This is a census data set, has information about people, including some demographic information, information about, are they people in the household and so on. We'll look at that information in a second. We go from there to cleaning the data, selecting certain columns, splitting the data, building a model, running the model on our testing data, and evaluating the result. Okay? So let me just take you to the data set, just so we can kind of get a sense for it. So this is the data set. We have information about people's age, the kind of job that they have, education, the number of years that they studied, marital status, occupation, relationship, race, gender, and so on. Okay? The last column in the data set is this column called income. It's a binary variable, meaning that there is only two possibilities. One possibility is that their income is less than or equal to 50,000, and the other possibility is that it is greater. Okay? And this is going to be our target variable. This is what we want to predict in this experiment. We want to use the data to come up with a way of predicting whether somebody's income is less than or equal to 50,000 or greater than 50,000. The model that we're using is right there. It's called a boosted decision tree. Okay. Now, you saw an example of a decision tree in the last talk. and a boosted decision tree is just an extension of that idea. It's this simple idea in machine learning, which says that we can have something like a decision tree that doesn't always do a very good job. It's not the perfect model, but we can take it and instead of running it once, we can run it multiple times. And then we can average out the results. And even though we don't have the best decision tree, even though our decision tree is not doing a really good job, when we run it multiple times and we average out the results, that turns out to be really, really good. Okay, so it's one way that we can start with a machine learning algorithm that isn't tuned to be really, really efficient or really do a good job of predicting, and end up with a machine learning algorithm that is actually performing really well. Okay, so I'm not going to talk about the ins and outs of this particular experiment because our focus is on R and Python, right? So instead of looking any further at the at some of these results, I'm going to bring you here to the search box where we're going to type execute, right? And here you can see execute Python script and execute R script. Okay? So let me take you back to the slide just so we can see where we are. So we were about here where we left off. So this is exactly what the execute R script that we're looking at here is represented in the slide. Okay? So I'm going to drag that in, and now I'm going to take this module, which splits the data into a training set and a test set, and I'm going to connect the first one, the first one here, and the second one right there. And then we can click on the execute R script module. And right there is a little pop-up window button that we can click on to open up our R script. Okay? So this script is kind of an example script that's there for us to start with. But in the document that we shared with you, I have a file called execute R script. And in here, I have some code. I'm going to copy this code, and I'm going to paste it into this window. Okay? Then I'm going to hit OK and select the module and hit Run. Okay, so what happens is we have some R code, and we're going to run it on the result on the two data sets that come out of the split data module. And the R code, let's just take a look at it. You don't, it's not too much code, so even if you're not familiar with R, you can kind of follow along. First of all, the code is going to go and take the first data set. So this is the data set that comes out of this particular node and feeds right there into, if you hold your mouse over right there, it says data set 1. So that's the data set. And we're going to take that and we're going to put it into an R data set we call train.df. And we're going to take the second data set, which is right there, and we're going to put that into test.df. Then we're going to tell R to give us summaries for both of those data sets. And we're going to tell R to give us counts for the different income levels for each of those data sets. Okay, so this says go to the train data set in the column called income, and the table is just going to give us, the table function is just going to give us counts. Finally, we take those counts and we put them into a data frame, and we also ask for proportions from those counts. Okay? So why are we doing this? Let's first look at the results, and I'll explain the idea behind it. Okay, so To look at the results, I'm just going to do a right click on the execute R script module. And here we have view log. There is an output log and an error log. Okay? Because the code has been double checked by me, there's not going to be any errors. And any output that is generated by the code is going to go into the output log. Okay, so we're going to open this. It looks a little bit nasty, but if we scroll down, we can start seeing the R code. So this is the first place where we see some R results. If you've worked with R, this should look somewhat familiar. So in our code, we said, give me a summary of the training data set. And this is what came out of it. Then we ask for a summary of the, there's actually more. Then we ask for a summary of the test data set. And finally, here we created a table called result. And result is shown right here. Okay? So what we wanted to do here is, since we're splitting the data between training and testing, which is something that we have to do so we can evaluate the model, we just wanted to make sure that in both data sets, we have approximately the same proportion of people that are within each income level. Okay? So in the training data set, I have about 75% of people whose income level is below 50,000. And in the testing data set, it's about 76. Right? So it's the same proportion approximately. And that leaves about 25% within each of the, within the training and the testing data set respectively, whose income level is 50,000 or above. Okay? So I'm going to close this and come back to the R module here. Okay? So, so that's it. That's an example of dragging an R module into an experiment and being able to look at what comes out of intermediate data that comes out of a particular module using R. Right? This is not the only way that we could have done this. We could have done this with other functionality that's built into Azure ML. Right? So there are a lot of different modules in here, including modules for summarizing data. Right? But the goal of my presentation is for those of you who know R or Python to show you how those languages integrate with the Azure ML Studio. And so the intermediate data that has resulted from you running the split data module can be dragged in here into an execute R script module, and then we run some code and we can analyze that data easily. Okay? One thing that you may have noticed looking at this is that, first of all, our code is fairly short. Right? We don't have too much code. Second, I already ran the code. I checked to make sure that it wasn't going to return any errors. If we got errors, we would have to go in here into error log. And because we don't have any errors, it says there is nothing for us to see. But it's kind of a pain to develop code like this. Right? So most of the time, when we are beginning from scratch, this is not the place that we go to develop our R code. Anyone who's used R is probably familiar with RStudio. If you are a user of Visual Studio, you can also use R tools for Visual Studio, which was recently released by Microsoft. Right, so there are some very powerful IDEs that we can use for running R code. Once we test the code and we make sure that it's more or less error-free, we can come in here and we can paste the code and then we can run it. Right? So the thing that I want to emphasize above all in this case, in the case of the execute R script module, is that it's not an ideal place to test your code because it's a very limited environment. Right? If you need to debug your code, this might not be the best place to do it. Okay, so we will see when we get to notebooks a much better place to do that sort of development. But before we do that, I have one last thing that I want to show you about the execute R script before we move on to notebooks. Okay, so notice that in here there is a third little place that we haven't used yet. And if we hold our mouse over it, it says script bundle zip. Right? This is how we can feed some script or some R data file or anything that we want our script to be able to read from into this module. So for that, I have prepared a little zipped file. If we go into this zipped file, we can see the same execute R script that we had before. So essentially what I did, in fact, I can delete this and I can recreate it. The only thing I did is I came here and I used Windows here to send my script into a zipped file, which I called my script. Okay. Now, I'm going to go back to the studio, and I'm going to go here to data. Here is where we have some data sets that we can look at. Notice that my script is already showing here, so let me delete that, and I can read it back in. Okay. Okay, so I deleted my the script that I had imported earlier, so I'm going to bring it back in. So we go to New, from Local, and from here I can go and select my script, and notice that it already knows that this is a zipped file. If you want, you can provide a description for what sort of information is in there. And I'm going to hit the little check mark there. And it takes a little bit of time, but when it's done, you should be able to see your zipped file in here. So what sort of information do we usually put there? So in my case, the information that is there is just an R script. Right? But it could also be what we call an R data file. That is, some file that R can go and open, and in it you're going to have some functions or some variables that you need to have access to. Right? So it's basically anything that is readable by R and that you need in order to run your R code. Okay, so we can see that there in data sets. I'm going to go back now to experiments. I'm going to reopen my experiment. And I'm going to click on Save Datasets. And we can see that under My Datasets, there is my script.zip. I can go ahead and drag that in and then connect it to the R script. And now, if I have something that my R script needs to run that is stored inside of this zipped file, it now has access to it. Okay, so let's go and change the code to show you how this would look like. So I'm going to go back to here, and I'm just going to select this one line of code and replace everything in here with that line of code. Okay, so what this does is it says, I want you to run the script that we ran just 5 minutes ago, but this time the script is not in here, the script is in the zipped file, and I want you to go and source it directly. Right? So we're going to run the same script as before, but now instead of pasting all of that code inside of this window, we have the code sitting somewhere in a zipped file, and that zipped file is connected to the execute R script module. So we can go ahead and run it. Let me close that and hit run. And so it takes a moment, but essentially once you start seeing the little round thingy there, that means that your R script is running. And when we see the check mark, it means that it finished running. Okay? And once again, I can do a right click on the module, go to view log, output log, and if everything worked successfully, I should see the same output as before. So scrolling down, we can see once again, here's some output, here's some other output, the summary for the test data, and finally here's the table with the counts and proportions of the different income categories for the training data and the test data. Okay? So we were able to reproduce our R script and the results by storing them in a zipped file and then running that directly from the execute R script module. Okay, so let me go back to the presentation here. And we are now here. Okay, so that was great. We can run R from inside Azure. It's a little strange. We have this little execute R script. It doesn't really allow us a way to debug the code. It's not really a suitable environment for developing code. So the only thing that we can do is we can maybe take a sample of the data. We can use RStudio or Visual Studio to run our R code, test it, make sure that it works, and when we know that it's going to work more or less bug-free, we can copy that code, we can paste it into the execute R script module, and we can run it. Okay, so that seems like almost of a half solution, right? If we have something like RStudio or Visual Studio, if we have an environment that is really powerful, why would we want to use execute R script, right? And that sort of gives you an idea of situations where we actually use that. Most of the time, it's going to be something really small. We need to double check some results. We need to quickly look at some summary statistics for the intermediate data that we created. And because we're using R, because we know all the R ways of doing it, execute R script is just a way that we can do it really quickly from within an Azure experiment. Okay. However, this is the second way that we can run R code inside of Azure ML. And we're going to be using what's called a notebook. So notebooks, for Python users, that's something that you've probably encountered before. A notebook is just an interactive document, a combination of some markdown, some Python code, and some results that are generated by the code. And the markdown renders into HTML, so we have this live document, that is interactive. We can change the code, we can rerun pieces of the document. And so it's a really ideal place for developing code and creating a report. When we get to the notebook, you'll see that we can essentially shift-enter our way down the notebook to the end of the document. Okay? So there are still some capabilities that are missing from notebooks. They are not as powerful as IDEs like Visual Studio or RStudio in the case of R. But it's coming. It's definitely, there is a lot of work behind it. It is not just Microsoft. There is a huge development going on behind notebooks, and people are trying to make it better and better and more extensible. So it's something that people are paying a lot of attention to, right? And we're going to see in the next demo how to use a notebook. Okay. So I'm going to go back to the original data at the very top of the experiment. And I'm going to select that data. And if you notice, one of the options that we have here when I do a right click is open a new notebook. Okay? And then we have 3 choices, Python 3, Python 2, and R. Okay? And because I'm an R guy, I'm going to use R, but it looks pretty much the same if you use Python. There are some differences. The Python notebooks are actually a little bit more powerful than the R notebooks. So R is still kind of in a more basic phase, but it's catching up with Python. Okay, one of the things about the notebook is when you select data and you launch a new notebook, there's already some code sitting there for us so that we can load the data. And as soon as we load the data, we can start analyzing it. Okay, so this is some R code. It's going to use the Azure ML library in R. And in that library, we have a function called download.datasets to download the dataset that was sitting in the Azure experiment. Right. And the way that we run this particular cell in the notebook is Shift-Enter. So I press Shift-Enter. You can see a star there. The star means that the code is running. As soon as you see a number, it means it finished running. Okay? So now I can go to the next cell and once again hit Shift-Enter, and now I can see my data. Right? So in the first cell, we loaded the data into a data frame in R called DAT. And in the next cell, we use the head function in R to look at the first 6 rows of the data. Okay? And so there they are, right? And now I can, basically just keep going. So I can say right here, summary DAT, press Shift-Enter, and here I can see a summary of the data, right? So everything that's in here is right now R code. Of course, we could go right here and select Markdown, and now we can just type some text, right? So I'm going to say something like, there are about 32,000 rows in the data. When I press Shift-Enter here, the Markdown was rendered into HTML, and so there is text in the data, right? So this is essentially a document, but it's a document in which we have some code that we can run live. Right? And this is the exciting thing about notebooks. Right? Every time you come back here, you can make any change that you want to the data. So I could say right here, just give me the summary of the first 4 columns in the data, and then press Shift-Enter, and suddenly your document regenerates with the new result. Okay. So that's a notebook. Now I'm going to close this notebook by going to File, Close, and Halt. Okay? And it's going to leave the page and take me back to the experiment. In here, I have a little notebook icon, and this is where I can see all of my notebooks. I'm going to click on that. And the notebook that we just created is showing up right here. Okay, so I'm going to delete this. And the reason I'm going to delete it is because we have another notebook in the shared directory that we're going to load now. And that notebook is a notebook that has already been created for us. So I'm going to say New. And in here, I have an option for uploading a notebook. So I hit Upload, choose File, and here's the notebook that I want to bring in. Finally, I have to tell it that it's an R notebook. And then you upload your notebook, and here it is. Okay. We can now open this. It's very similar to the notebook that we were just looking at, with just more code in it. Okay? So once again, we have our data. It's the same data that was in the experiment. And now I'm going to just from the top I'm going to Shift Enter and keep going down and run some R code. Okay? So as we do this, I'm going to point out certain aspects of what's happening. And if you are an R programmer, this is going to look familiar. If not, kind of bear with me. But essentially, notice that all of the columns in our data that are categorical are showing up as character columns. So we have some work that we need to do in R. We need to convert those into factors. So here I have some code that's going to turn those columns into a factor. When we run str again, we can see that the columns have been turned into factors. Now we can ask for counts, and we can see the number of people that are below and above 50,000. And here I'm going to install a package. Okay, so some packages like ggplot2 are already installed in the notebook. We don't have to install it to be able to use it. Other packages are missing right now, but that's okay. By just typing install.packages, we can go ahead and install the packages in the notebook. Okay? It usually takes a little bit of time. Notice that the star is still showing up, so whenever you see that star, you want to wait for your code to finish running before you can go to the next cell. If you go and run it anyway, it's not going to be a problem. It's just going to wait for that cell to finish running before it runs the next cell. But it's just a good idea to be a little bit more proactive in making sure that you don't select too many cells and run them. Okay. So let's give that a moment to finish. And while it's happening, I'm going to take you through the rest of sort of what's happening with the code. So what this notebook is going to do is it's going to redo our experiment. Right? The experiment that we have right here in Azure ML. Let me go back to the experiment. This experiment has been performed using the Azure ML interface. Right? We had some modules that we dragged into the experiment. We connected them. Each module does a specific thing. The first one is the data. Then we have cleaning some missing data. Then we have selecting some columns. Then we have a module for splitting the data, and so on. What we're going to do with the notebook is we're going to recreate all of that within R. Right? So we're basically bypassing the experiment, and we are redoing all of that using R to show you how that works when we use R. Okay. So this is still running. It's usually not this slow. So I'll just wait for now. Another thing about the notebooks is right here you have a little sign that says the kernel is busy. So that means you have some R code that's running. You need to wait that it finishes. And now it's done. So it installed the Caret package. Caret is a library for doing machine learning. We're going to use Caret in this case to partition the data. So this function, create data partition, does exactly the same thing as the split data module in Azure ML does. Okay. Then we split the data into training and test set, and then we have a package that we're installing here called ADA-bag. What ADA-bag does is it builds a boosted decision tree for us. So if I scroll down right here in Azure ML, we have a module for building boosted decision trees. In R, we have a package for doing the same. And we're going to use the package in R to run a boosted decision tree instead of the Azure ML module. Okay, so right now, we're running this cell, and it's creating our model for us. So we can see that we have a function called boosting for running boosted decision trees. We're telling it that we want to predict on income. So our goal is to build a model that's going to predict income level based on all of the other variables in the data. So what the period over there says is use everything else in the data to predict. We only build the model on the training data, right? So there we can see data train, and finally some arguments for specifying the type of model that we want to build. It took about 11 seconds for the model to build. And when it's done, we can use ggplot2 to look at the columns in the data that were the most important to the boosted decision tree. So we can see that relationship is the most important column, followed by capital gain, followed by education. So if you want to know somebody's income level, you would start at the left here, and you would slowly make your way to the right. And as you move to the right, the columns that show up are less and less important in deciding what income level should be. Okay. Here's what we call a confusion matrix. So we can see that of the people whose income level is less than 50,000, this is the number of people that we correctly predicted to have income levels less than 50,000. So the numbers in the off diagonal are misclassifications, and the numbers in the diagonal are the classifications that are the correct classifications. The confusion matrix that we have here was built on the training data. Here's the confusion matrix on the testing data. Now, that's the one that we usually care about, right? We build our model on the training data, but when we want to see how well we performed, we look at the performance of the model, not on the training data, but on the testing data. There is a package called E1071, a very useful R package for getting a bunch of summary statistics. So here are some summary statistics, including the confusion matrix, but in addition to that, we see a lot of important statistics. Sensitivity, specificity are the ones that we usually look at, and so on. Okay, so finally, here's a package for building an ROC plot, and once we finish installing the library, we can run that package, and we can look at our ROC plot right here. Okay. So where is that in the Azure experiment? If I come down here to evaluate model, and we go to evaluation results, visualize, we can see the ROC plot showing up here. If I scroll down a little bit, we can see the statistics, true positive, false negative, accuracy, precision. You can tell that they're not exactly the same as what we saw in R, but they're more or less related statistics. Okay? So here's what Azure is showing us, and here's what R is showing us. Okay? So the goal of this particular exercise was to show you how we can use a notebook to recreate our R experiment and completely bypass the Azure Studio. Right? And if you are an R user, if you are an R expert, this might be the way that you prefer to run your code. Right? There is advantages and disadvantages in each case. To give you a simple example, here we have some interactivity going on. So I can go ahead and slide this over, and as I slide it over, I am changing my probability threshold. And as we change the probability threshold, we can see that our metrics are changing. The precision, in fact, we can scroll all the way to the left, and we can see that we have perfect recall, but the precision is pretty low. And if we go all the way to the right, we have perfect precision, and the recall is next to 0. Okay? So we have some interactivity going on in the Azure experiment. And in R, we probably have to hard code that so that we can we can look at the metrics as they change. But otherwise, the results are the same. The AUCs, the ROC plots look very similar. And if we look at the area under the curve, we have an area under the curve of 0.91 here. And if we go back to the experiment, the area under the curve is also shown in evaluate model. If I can find it, right there, 0.914. Okay, so both of these did approximately the same thing. They returned a model that's approximately the same model with the same performance. One was using the Azure ML experiment, dragging the nodes inside and building this sort of data flow. The other one was using a notebook and relying 100% on R to do all of the work from reading the data to returning the ROC plot. Okay, so that's it. So we have two ways that we saw how we can interact with R or Python. I only used R for my example, but it would be pretty much the same setup for Python inside of an Azure ML experiment. One was the execute R script. It's a limited environment where we can quickly run some R code and look at some short results. And the other one was the notebook, which is extensible. We can install libraries inside of it, and we can generate this document as we develop our code, right? And this document is going to be this is going to be the best way that we can sort of develop our code, but have a notebook that is running on the Azure infrastructure and reaching for data that is inside of Azure. So that's the end of my presentation. I hope to talk to all of you after the talk today, and hopefully get to help you out tomorrow and the day after as you work on the hackathon project. So thank you very much. We don't always have to be in competition with open source. We can work together and we can take what's best and build solutions with it. Okay, and today we're going to see an example of that with R and Python inside of Azure ML. Okay, so I'm not going to cover why Azure ML. I think by now you've seen enough presentations that we have a pretty good idea. But I will talk about sort of why we want to use open source technology. Maybe a little bit about R versus Python. It's kind of, these two languages are in some ways very similar, but each of them have certain strengths and weaknesses, and we'll talk a little bit about that. And then we'll move on straight to demos so that you can actually see this in action. Oops. Okay, so we saw Azure ML. Ted was doing a quick demonstration just before I came up here. And what I want to emphasize here is that we want to think of Azure ML as an environment where we can both develop and put into production. Okay? And this is very hard to accomplish. I've worked, for example, with some companies that were using R for development, because R is a language that is very it's very suitable for doing exploratory data analysis with, right? But when it came to putting the code into production, they would actually rewrite the code in some other language. My name is Seth Motarinejad. I'm a data scientist at Microsoft. And I'm going to talk to you today about using R and Python inside of Azure ML. Just to get started here, I have some questions. So how many here are R users? Okay, I see a few hands go up. Python users? Okay, there's usually more Python users than R users. How many here are data scientists or want to be data scientists? Okay, good. So a little bit about myself. I was in 2012, I joined Revolution Analytics, which was an R-based company. We provided consulting to our clients who wanted to use R for their analytics. And last year, Microsoft bought our company, and most of us joined Microsoft as employees. So I've been with Microsoft for about a year now, and it's kind of part of a big shift in the way that Microsoft is now approaching sort of open source technology. It's certainly not limited to just R and Python. For example, you may have heard that SQL Server is now in Linux as well. So there is a certain recognition that open source technology is here to stay, and that Microsoft Azure. Okay, so why open source tools, and which ones should we use? Okay. So one of the, probably I would say the biggest advantage of a language like R or Python is that it's interactive. And that means that you don't have to compile your code before you can start looking at results. That means that it comes with IDEs that are just really powerful. You can very quickly debug your code. And within a very short amount of time and a very little amount of typing, we go from raw data into some kind of analysis. We can produce plots, we can look at tables and charts, and we can get a pretty good sense of our data and what we can do with it, right? So ideal for EDA, which is exploratory data analysis. Very good tools for doing visualizations. A vast array of packages. This is especially true for R, where you have, thousands of statistical libraries for doing all kinds of analyses. Time series analyses, machine learning algorithm, analyses that are specific to a particular domain, such as genetics algorithm or bioinformatic algorithms, geographical data and GIS applications, and so on. Okay. And what we're going to see today is a special case of using notebooks. So that's going to be at the toward the end of the demo today, and it's going to essentially give us access to a place where we can develop code using R, but within the infrastructure of Azure ML. And finally, just kind of a quick note on some of the different because R was a little bit slow, for example, right? So we have these two forces that are a big part of doing data analysis. One is the people who develop code, who explore data, who want to understand all the capabilities. And the other one is the people who are trying to create actual applications out of that data. They want to think about a production environment. They want to think about stability. They want to think about the ability to scale. And one of the advantages of Microsoft Azure is the fact that some of the complexities that come up, some of the differences between, some of the hardships of kind of joining a development and production environment are abstracted away from us, and we can really begin to start thinking about a combined environment, a place where we can develop code, but as you saw, for example, you saw examples of it with turning an application into a web app. We went from a development environment very quickly into a production environment. Okay. So we have an environment that is powerful, it's integrated, and the big piece that my talk is going to focus on is that in addition to everything that we saw, it's extensible. It's extensible with open source languages, such as R and Python. Okay? And this is really important because a lot of people are using these languages. Like R and Python are here to stay. They are very popular among developers, among statisticians, and they are very extensible, and they continue to grow. And you can now put all of that power inside of this between R and Python. So Python, for those of you who've been using it, it's a very general purpose programming language, extremely popular and applicable in all kinds of different applications. So people use Python to build basic web apps with. They use it to do web scraping. They use it to build applications with. Nowadays, Python is also a very extensible has a very extensible machine learning library. Okay. R, on the other hand, not as much of a general purpose programming language, but definitely one that was R was built by statisticians. For statisticians, there is a huge repository of libraries that I mentioned before, of just statistical libraries and functionality that we can use. Okay, so building a machine learning model. So we saw an example of that just before I came on the podium here. And what we see in yellow is the place that we're going to focus on for now, right? So the last talk, we talked a little bit about kind of the cycle of a data scientist, right? So a data scientist usually begins with defining a business problem, thinking about the question that we're trying to answer. And from there, we go to collecting data and understanding the relationships between the columns in our data and everything that we have access to, right? So I would say, in most data science applications, we spend a lot of time on the first two. Then we get to the part in yellow, which is sort of putting it into operation, right?